covering that group of people. They are enthusiastic, but they can go away or walk away. And isn't there a common interest for a UN task to govern as a digital library that this open source code software shall so well be held for future as a scientific archive, as a cultural heritage? Because there's a lot of creativity about open source code software from people also in developmental countries. And it should be open not only for the scientific community, but also for the use of medical professionals in the health science. So isn't there an economic interest? And it cannot be of any agenda, I think. The implementation is that one cannot take responsibility for this open software on the long run. And that is why projects, when the persons go away, could fail. That's my question. Do you have the panel solution for that? Is that the same question of health to the United Nations?
Thank you very much. I think in health, really, I think the main issue is not whether something is open source or whether it's Linux or Microsoft or but rather the actual availability and the accessibility. I think so. Open source has a tremendous potential in healthcare, but it's difficult to ignore the proprietary tools that are out there. I mean, I think the real question is accessibility. Certainly, many of the proprietary software companies are very happy to make the products that are available at no reduced charge to some parts of the world for specific purposes. We have a tremendous experience in that already. I mean, I think it's important to use the right tools, and it's important that they be accessible and as accessible as possible everywhere.
Okay. Last question.
David Knowles, New Zealand, representing the Royal Society of New Zealand. A lot of people have been talking about access to technologies and ICTs. And I think the example of Purple, the first day, is an example where we have to think in terms of appropriate technologies, because then that's going to aid the access. Too often, for example, from my field, we've put wells in places where people then have to have nitrogen pumped to the well, and the power line is 10 kilometers away, and that's not an appropriate technology in that instance. So we have to think in terms of appropriate technologies, and at the same time, those are then often environmentally aware and appropriate. And good environmentalism is also good economics. I think we need to remember that as well.
Okay, will any of the rapporteurs want to
I think in the environmental session, it was coming clear, we don't want to get any technology. We want to get the technology as needed, as mature, as can be really used by the end user. We have to stop, and this was said many moments during the day. We should stop, getting technology push. We want the magic word, the user in the driving position. Maybe it's too much, but definitely want to get the user trying to communicate properly priorities, requirements, and that is the way in which we can make the things happening. Otherwise, there will be just a rejection.
Okay, well, I think that will be quite useful. Thank you so much for the comments made. I think it will be rather difficult to summarize everything you've said. But let me just give you my quick impression about some of the things that you have captured. First, I think, although it has not yet been mentioned here, but connectivity to the internet for all is a very important point. We should raise that with WSIS. I really would like all these schools
enough just to get connected. You must have the capacity to utilize the internet. And that is not a trivial matter. I think you need training, you need proper training in order to utilize properly what is really there, what is available in the internet. So the capacity to use the internet, I think, is something that's very important. And the ICT literacy programs should really be somehow encouraged in many of the developing countries. In the education section, I think this module of MIT open courseware is extremely important. And it's a model, I think, that has to be copied, as was mentioned by Mustafa Tayyip. Stanford University is doing it. But coming from the South, I would also like to see some of the universities in the South doing this. This should not be confined to universities in the North. But in the South, we have wonderful universities, very important institutions in India, in China, in Brazil. And I think some of the courses that are taught there are very high level, and they should really follow the model of the MIT open course. In this respect, I think the South-South cooperation in training and in education is absolutely critical. If we really want to maintain a good level of excellence in the developing countries, we really have to engage the best institutions that we have available in training students coming from the less privileged countries. And that is already happening, as was mentioned again by Mustafa Tayyip, and a number of countries, especially the big countries in the South, like Brazil, China, India, Mexico, have in fact offered large numbers of fellowships to students coming from other countries. And it's a huge commitment on their behalf. These are all covered by those countries as well. So we would like to see more of that. We would like to see more of the South-South cooperation in education and training programs. In the economic session, I think what really captured my mind is this beautiful example of how information technology can be developed in the rural areas. We empower the rural communities and women in particular. And we have the example in India of SMS1 University. I think this is a very good modality, and I hope that this sort of model can again be copied in Africa and elsewhere. It will provide, of course, economic benefits to the individuals, as well as it will create, of course, jobs for those who know jobs. In the environment, planners and decision makers need accurate and timely environmental information on sustainability. This is very important. And also this North-South collaboration to ensure the accessibility of reliable data, where we get the two policy makers, I think is very, very important. I think without reliable data, without good scientific evidence and information, no good decisions can be made by the government. So this is, I think, is something that is important. In health, a number of issues, including maximizing the use of existing indigenous knowledge in health. This is very important. Telemedicine and e-learning also is a critical issue. But giving priorities to basic health needs and integrating them with technology, this is something that also is important. And then we will talk about the digital divide. That's everybody talks about the digital divide. We're going to hear a lot about it in the next 2 days. And how to bridge that, I think, is an immense problem. And I'm sure that our discussion will take place in the next 2 days. But scientists must have a dynamic presence in the policy arena and the development of methods promoting S&T integrations. This is important. Without getting connections for policymakers, without the policymakers getting the right science advice, I don't think much can happen. And this is really a very important role for the scientific communities. How to interface with the decision makers, how to get the message across, how to be understood by the policymakers and by the media. This is something that is really lacking, especially in the developing countries. And we are beginning to see a number of academies of science now, in fact, in the advanced countries, getting involved in that, giving good advice to government and good advice to decision makers. But we would like to see this also in the developing countries. And that's why we have a program in the academic funders, the network of all the academies of the world, where the capacities of academics are actually addressed. How to build up the capacities of academics of science to enable them to provide services not only to scientific communities, but also to the issues also you have raised in the discussion and also panelists. I think what we really need to do is perhaps think a little bit about some of the major issues that we have raised here and feed this into this key message from the WSIS. If you agree, then we cannot, of course, do everything there for all the reports, but we really have to pick a few key issues and somehow present those to the Director General of CERN to see if some of this can actually be mentioned in his talk. So with this, if there are any more questions, I would be happy to answer them. If not, I think we have received our time. It's not the report of the board. If you don't have any questions, then I would like to close the session. I think there's going to be a coffee break, perhaps a short one. And the next session, I think, starts at 4 o'clock. Okay? Thank you very much.
Sorry. Yeah, that's true. Of course, I think that if we do the, if we turn on the camera beforehand, or we do, we'll have the document of like how we want to see how the process is started, so that we can see how it is. So that's why it's a good opportunity. So let's just do it.
While we're with him about it, see if you have any major judgments of it, but you got me?
Okay. Well, let's say you like the time.
Yeah, 9 o'clock is good for you.
Okay.
If that's good for you.
Yeah.
You want to slide it right away, but you wouldn't want to go later than 11.
No, I would say what we need to do is take a bus, like the Expo, and then take a taxi from there just to save some money. Like you said, it's about 2 kilometers inside.
Filming against their will.
Yeah. Well, it's a
Private conversation.
yeah. That's the audio is bad. Yeah, the audio is very bad. But we showed the film today. We showed the film. Yeah. So I'll send you a DVD.
Okay, except I don't have facility to watch.
Well, you have a
DVD.
computer.
Yeah.
Right. It'll play on the computer. Yeah. But it's just a fun thing, and it's like a lot of good music. If you like, people that don't like the film can like the music.
That's good.
Sí, ya lo dejan. Discúlpame. Sí.
Great talk. Really enjoyed it.
Digital camera.
Yeah, well, we showed our DVD today at the education session.
I'm sorry, I was at a technology session, but that's been my
Well, I can't say it would have been better, but I bet our music would have been better. No, I can send you one though. I can just get play it on your computer. It's only 17 minutes, but I'll tell you, the funny part of that is the people.
And that's my colleague, the chairman. You see, I'm in the front bench there as the vice chairman. Vice president, I did the speech of thanks.
Really?
The vice president, yeah.
Well, I would say that if our American legislators were as good as yourself, then our country would probably be a lot better off. I don't know that ours are actually educated. And we're proud of it. I'm very proud to work here. You didn't see the film today? No. Yeah. You were in this section. Well, the first presenter who was on a conference call from the U.S. had something on African Virtual University, and what people didn't know, unless they knew more than the audience here, is that was actually one of the problematic sites featured in our film. I didn't give names to the places that we showed, but it was actually what African Virtual University home base is actually at Jomo Kenyatta University, or was until it changed. And that's one of the sites that we showed in the film. At the time we went there, the chief sort of librarian of the African Virtual University didn't have email connectivity, and the vice chancellor of the university would have the secretary dial Nairobi all day long just to send an email. I mean, it was a joke. That was 3 years ago. It's better now, but to me, this really kind of says it all.
Well, what you said just before, I could see as being taken one way or another. Whereas this, to me, is a very good message that whoever is in charge.
Yeah, it's not a high priority.
It's a message that I've heard echoed along many lines about it. Initially, many people complaining, and many of these guys give us the impression that they want our money to do their little fun thing,
right,
and then disappear and never.
The strange thing about it is you would actually expect them to be here because this is a per diem. So, if they could get some money to come to CERN and get a per diem, they would normally.
I'll make this one step further. That's people about this very kind of thing, where the guy is actually getting his per diem, but is walking around Geneva.
Oh, really? Oh.
I've heard exactly the same comment.
Really?
ICTP. I mean, this is totally off the record.
Oh, okay. That people come to ICTP and then just cruise around.
We'll sleep because back of the course the first day so that they get the main and I know that it's common.
Yeah. Well, that's, the people that
don't ever cite me.
No, I mean, it's so well known as not to need a citation, but it's interesting because you are pretty well placed to know that. And I think for me the issue is, you're doing a project, but really what it amounts to is you show a website and you show your page and you say, this is our project, this is what we're doing. But then when you go there, this is my test. I want to go there and see what they're doing on a daily basis. And usually it's nothing.
Unfortunately.
Yeah.
It's time to get in and sit down.
Okay, let's do it.
You're going to have to sneak me in because they're not letting me in. So, okay.
Well, this is the last session of the CERN event, World of Science and the Information Society, and I think Tim Berners-Lee has come, actually. He's here. He was snowed in Boston yesterday.
The conference at CERN on the World of Science and the Information Society. My name is Frank Rose. I'm moderating this session. I'm a contributing editor at Wired. And as a journalist, I've written on science, technology, and popular culture for magazines from Esquire to Rolling Stone, occasionally for science magazines as well. First, we're going to hear from Tim Berners-Lee, who is, I'm sure you know, the person who created the World Wide Web. Tim?
Hello, it's good to be back. And I must, first of all, I must apologize for the problems I have. I prepared a talk, and then I heard one more person after another say that I was going to talk about the semantic web. Well, I hadn't intended to do that. I just wanted to say a little bit of mother but not mine about the role of science in society, which we know is the information society, which we know is very important. And I'm not really going to the semantic web because I thought it would take too many slides. But I've been put under some pressure to put in the semantic web bit. So I'm resolving that I'm not now responsible for your time. This will overrun us. So there you go. So I'm going to start with some of the original talk, and there will be a time which we'll switch across And if you're watching this remotely, then it's obviously a good idea to watch the slides on your own browser. And this first slide, in green, illegibly, perhaps on your monitor, but there is the URL of the slide, so you can follow along yourself and you don't have to rely on the video for the slide. So what's the web? It's fundamentally, it's a decentralized thing, and practically when we really use it, it can come to fractal. And that's what I'm going to discuss just a little bit. So this initial talk was about the invention of the web, its genesis here at CERN. Well, here at CERN without the red carpet and with blackboards. And I was very tempted to go and get a piece of chalk. Draw all the curtains aside and go use a piece of chalk just to get back to basics. But I'll resist the temptation. So going back then, okay, this is the difficult thing now. It used to be difficult to explain what the web would be like. Now it's difficult to explain why it was difficult, because it's so obvious to everybody. But back in the 1980s, at CERN, it was an exciting place to be. Lots and lots of information systems on different computers, on different networks, all incompatible. So the idea was that one should be able to communicate by sharing information. Now, there are different models of communication. One of the models of communication is that I say a whole lot of things. I send you a lot of messages. And then later on, after you've digested them, and maybe understood them, or maybe not, you send me a lot of messages back. A lot of communication works like that. But there's another way of looking at it. And that is that we decide to build something together. And we get out a big sheet of paper. And we sit down next to it. And we fight over who has the red pen. And then we draw we erase. We use that, right? We'll use that blackboard. And that's interesting because as we go through that process, we are building something together. We end up building a document which has got common terms that we understand. So the idea of the web was to be able to do that, but across the internet. And hopefully, because we're using computers, to be able to not only have the finished product, but also track how we work. So I call that interactivity at the time. Then people said that forms on websites were interactive, so I then call it intercreativity. So the need was for an intercreative system, and the challenge then was that at CERN there was a lot of data. There is a lot of data. There was a lot of information about how things worked. It was not practically available. It was on a computer, on a network, but not on your computer, not on your network. And if you could get hold of it, even on a floppy disk, and put it on your machine, it would be in an incompatible format. So there was a lot of heterogeneity. Okay, now heterogeneity is a good thing. Diversity is a good thing. To run a place like CERN, you don't want to just tell everybody to buy the same computer system. You don't want to just tell them to all use the same mail reading software, especially if it's the sort that distributes viruses. So it's good to have a variety of types of machine, of sorts of operating system in a large organization, especially when it's both people coming from lots of different home institutes. And because people at CERN, of course, come from different home institutes, they come with instructions and customs from those home institutes. And they don't necessarily want to change them in response to some hierarchy all over CERN. So CERN was an interesting place to be. It was advanced. It was it was somewhere where in 1989 most people had some sort of workstation on their desk, which was unusual then, and a place where the internet, the network connectivity had just arrived. Well, the network connectivity had been there for a while, but it was just becoming politically all right to talk about the internet instead of ISO European protocol. So in a way, CERN was interesting as a microcosm of the world, a sort of substrate. And the solution, of course, it's the web, taking the idea of hypertext, taking the internet, which I did not invent. That was 20 years beforehand, okay? I just did the www. And how did I do the www? I just took all the information systems out there and looked in general. What is the abstract information system which would be sufficiently general, sufficiently flexible, such that each of those systems could be a part of it? So that meant I wanted every system out there to be part of the World Wide Web. And to ask something that big of everybody, I knew that I could not tell them all to write an SGML, or tell them all to store it on the mainframe, or tell them all to store it on the Mac or a PC. and to let people store it however they like. To be as flexible as possible. So hence this design constraint on the web, which is still with us, is still very important, of minimal constraint. The web architecture constrains as little as possible. It shouldn't constrain how you think. It shouldn't tell you how to organize your data. It shouldn't tell you what software to use. It should allow you to invent new applications within the web whenever you feel like it. So very quickly, here's some milestones. I wrote a memo in 1989 suggesting the idea. Really, remember, this is not a software tools organization. It's primarily a physics lab. So very properly, it has got all sorts of traps set up to stop people who are supposed to be doing physics having a great time programming just whatever they like. And this is very necessary because programming environments are extremely fun for anybody who's got any creativity in a computer, and certainly that applies to almost all the people at CERN. So everybody would be off to design all kinds of things unless you weren't careful that you made sure you bought off the shelf everything. So the very proper response to the web idea was, if it's a good idea, you should be able to get it shrink wrapped. Go buy it off the shelf. If it's not available off the shelf, then it must be a stupid idea. So the memo didn't get very much response. But in 1990, my boss at the time, Mike Sendel, he suggested that I get a next computer. Those are the black computers, which are on the outside sort of square and black, and the inside very much like what an OS X Mac looks like at the moment. And he suggested that we play around with this new type of computer at the same time. Why not do some sort of experimental project just to test it out? Why not do that hypothesis thing? So I started programming in the fall of 1990. By Christmas had I think the date on the first World Wide Web program when I actually released was the 25th of December. I wasn't working on the 25th of December, but I can remember the date. And I released that, generally walked it around the high-end physics, and put it out on the internet on some general news groups that summer. And in 92, remember this is a program that only runs on the Next. And the Next was not quite compatible with other systems. But in 1992, Payway and a group of students and the Airwise group of students in Finland produced two browsers that ran on Windows, which was great. So then the CERN Computer Newsletter explained how to install Viola if you wanted to browse the web on a Unix machine. Then in 1993, Mosaic came out from NCSA, Mark Andreessen supporting that very well, listening to users, turning it around very fast, and making it easy to install, easy to use, and contributing to a very dramatic growth. In fact, the growth of the load on the first web server, which was in fact the first web client, which is my computer, the load went up very steadily by a factor of 10 every year for the first year. So, for a while it was like pushing a bobsled, and then it was going to be, and then there's a critical time, I imagine, I've never done it. If you have, I imagine that there's a time when you're pushing a bobsled, but you realize you have to get in and steer, and you probably have to time it kind of accurately. And for me, it was about 1993, 1994, that people were starting to say, look, it's obviously going to take off. We are completely reorganizing our company around the internet and the web. We want to know where will the standards be defined. We need a group to meet with the other people who think this is important. Why didn't you form a consortium, more or less? So we formed a consortium in 1994, based initially it was organized between MIT and CERN, and then it was set up with the hosts, the MIT and States, India in France, and later we added Cairo University. Now we have a lot of hosts, we have a lot of offices in other countries. So there's a point of there's an advantage of having sites on the web, there's links to other stuff. So there are some milestones, that's the background. And these are the fundamental properties of the web. Okay, the idea of the web is that there is only one, it doesn't constrain anything, it must be universal. Universal along lots of dimensions. It must run on any hardware. It must run over any network. Well, originally, actually, there were DECnet colon URIs, and there were gateways from DECnet into the internet. The DECnet stuff faded very quickly as the back of the next machines actually lost internet on them. But initially, it had to run over every network. And now, the internet has done a great job by making that no longer necessary. Because by being ubiquitous and by being very flexible, we can now just run over the internet. Our life is much simpler. clean interface between the web and the underlying network. It must run under for any operating system software, and obviously any application software, any browser. It's very important that anybody could write a browser, and anybody should write tools. Obviously that's fundamental to the way the web works and the fact that the web exists. It's amazing that sometimes people still seem to forget it when they make websites which will only work, which say best used using a particular browser. So those are just some of the dimensions in which it should be universal. Clearly it has to work for any language. It's got to be international. Not only is the character set, so it's not just the fact that now we've got XML which uses Unicode, but there are all kinds of ways in which you can vary your culture. And you can assume that the given name is a first name or something. You can vary it, you can put little pieces of your culture into a piece of software if you write it, if you're not careful, or even into an internet standard. It must be able to, it should be able to work with junk. Actually, some junk becomes important. It's important to be able to publish stuff which is not very valuable, because the valuable stuff actually starts off that way, and it's important to be able to discuss and deal with information as it goes through the process. So whether it's very polished work or it's the idea which will become one, it should still be publishable on the web. A lot of information systems before that were only really made the assumption that we're only publishing the technical reports which will reach a certain standard. It must work for personal data as well as private data, as well as public data. A lot of the data in your real life, the stuff that's most important to you, is in your address book, in your calendar. Some of the experimental data, you may be keeping those to yourself, but you don't want to release it until you test it, of course. And so it must be able to be accessible by anybody. A very large proportion, depending on how you count, 20% is a good number of people who actually have some sort of disability, which means that they have to adapt their computer somehow and look at your website. You must take that into account. Because guidelines now on how to do that. And there's one other dimension along which data varies. It's about information values, I should say. And I can go back to the original name of the Computing and Network Division. I don't know what it's called now. But when originally it was called Data and Documents, Documentation y Document, DD. And I guess that would turn good to, that was sort of, that would change, but it sounded so silly, but it's really interesting, in fact. Because data and documents, what's data and documents? What's the difference? Documents are things that you read, and data is stuff you stick in a computer. Data is boring to read, but documents are things that computers can't process. So there's these two types of stuff out there. And the data is much more useful because you can process it. And documentation is much more exciting because you can read it and surface it, listen to it, watch it, play in it, and walk through it, depending on what medium you have. So the web has encompassed all of those things. And of course, what's really happened since we started is that the web has actually taken off along the document direction. And what the semantic web is saying, hey, all that data out there, it's not out there as data so we can process it. And none of the computers understand when you have data on the web what it means. It's all there for people, not for computers. So this is the point where we follow the links to the manufacturer. And so now, in response to popular request, a very, very, very quick introduction to the semantic web. If I talk really, really too fast, then you can tell me to slow down. Semantic web is about exchanging data, and it's about exchanging data between machines in such a way that the machine in some way knows what it's about. What do you mean knows what it's about? But if I download a bank statement, it comes down currently in a sort of HTML format. I put it in my computer, and if I drop it on an application that understands bank statements, it'll display, I'll be able to do financial processing, I'll be able to do bar charts and things. Because that application has been written to understand those particular texts. Total, date. And a lot of the confusion, the fact that you can't reuse that data is that nobody, it just says date there. It doesn't say really what it means by date. So on the semantic web, if you're going to publish that data, then you don't just say date, you actually use a form of XML, which is what called a namespace, but the result is that instead of actually using a date, really, you're using a name which is really a web address. http://example.com 2002 standard 6 # color instead of color. Now, you can argue about whether colour should have a unit and what colour actually means when you just say the word colour, when you use an XML tag colour. But when you use it as a URI, somebody owns that. So it means that's what I mean by colour. When we measured colour on that day, we measured that sort of colour. If you want to find out more about what that meant, then come and ask me. But up till now, don't make any assumptions about what that really means. Now, obviously, if nobody makes any assumptions about what it means, you can't use it. So the semantic web works by people sharing these things. And of course, the web is good for that. Well, it's meant for it. The basic atom of the semantic web is just one piece of data. Most of the information in our lives is in relational databases, and the atomic unit of the relational database is the cell. It's where something, a horizontal row is an object, and a vertical row is a property, and where the intersection just records that object, so one particular property has a given value. Subject, verb, object. My car, color, red. Three things. Triples. It's all made out of triples. When you draw circles and arrows on the diagram on the blackboard, which is my normal way of communicating when I'm not constrained by the curtains, then you always each arc represents a relationship, a binary relationship with a subject, with an object, and importantly, the arc of the time. So we have typed arcs. Both the subject and the property and the value typically are represented, identified by URIs. And this stuff is called RDF. It's a standard WSIS recommendation. You can encode it in XML, and you can exchange data like that. And when you find a table, of course, you can encode it in circles and arrows. You find, because the circles and arrows, these arrows are very, very flexible. So you can take your data and encode it in circles and arrows, and you can take a tree. Lots of data is a tree. You can encode that in circles and arrows too. And you can use the same URIs for the same thing, whether it's information in a tree, from a tree or from a table. And when you use the same URI for something, that's great, because when you take data from the same thing, color and color, or run 16 and run 16, and you put those data together, then you end up with a combined graph in which the data is merged. Now, that looks very simple. And that's the great thing about RDF data, is that, for example, when you take a blue document in which you find that somebody is attending a meeting, for example, this person on the left, the blob on the left is attending the meeting represented by this blob, which has a home page, and you add to it the information you got from a, say, a green document and a red document, the RDF data merges just like that. Now, you can't do that with XML. You can't do that with XML without interviewing the people who wrote the XML applications and finding out what they meant by all those tags, and then writing a new XML schema to express the result. In RDF, you basically concatenate the files, just load more than. So semantic web is about using the same URIs for things. When you think about tables, think how many times you make a table that somebody makes a table and they write at the top something like color, or numerically they write zip code, and you will write postal code. And in fact, when people write zip code, very often they mean just a 5-digit zip code. They mean exactly the same thing, but they never tell the computer that this is the same thing as this. And it's very useful to tell the computer, particularly when you've got a huge enzyme database and a huge protein database, and they share a very large number of concepts, but nobody's told the computer yet. So the semantic web is about telling the computer this is the same as this. Think of it as semantic web. Like this concept is the same as this concept. That sort of dawn of understanding is something sometimes it's very hard work to get to. So, but it's all about, but then all of it becomes the job of trying to find common terms. And you know what that is. Finding common terms is hard work. It's like making standards. When you do it in a small group, it's easy. When you do it by yourself, whereas groups, the proteomics group meet the genomics group and they decide they want to talk about what a protein is, then there may be a little bit of discussion about what really counts as a protein and what doesn't. So, well, and sometimes it's worth it, sometimes you don't bother. So you end up with different communities of different sizes, and you have a certain amount of overlap. You see, what's very fundamentally different here between the semantic web and a lot of the knowledge representation projects in the past is that the knowledge representation projects tended to make one big tree, like the Cypher project. We'll start off, everything is a thing, and then there are, well, there are animate things and inanimate things. We'll go on from there until we have everything, including you, sir, in our ontology, in the big Dewey Decimal System. And that doesn't work. because everybody has a different way of looking at data. So really, we need the system has to be completely web-like. You don't expect total consistency. You expect people to have made inconsistent definitions and so on. This is my attempt to try and show how you may have lots of different applications, that's the circles, around in your life, and in fact they share concepts, just like stations on the metro share different colored lines. So if you have a photo, it may have a timestamp, that's all the camera puts on it. But as a result, you can compare that with your calendar. Your calendar knows where you are, knows who you were meeting with, so it might be useful for searching for people in the photograph, and if the calendar tells you where you were, then you can work out where the photograph was taken, and so on. And so semantic web is about connecting together different applications. I'm intrigued too on that. So, just one thing to notice that in this company, the person works for a company where the customer relationship management group share a lot of data and a lot of concepts from other parts of the company. They share some technical concepts with engineering. They share the concept of the company part number. And that part number actually is in the catalog, which is public, and it's in the engineering information, which is not public, and it's in the CRM database, which is actually very, very private. But that concept was not shared with anybody else, because the company just defined the part number and did not share it elsewhere. So some concepts are not global. So, remember, this is not a tree. Your life is a web, your data is a web. You need something you can express as a web. In enterprise software at the moment, people look at connecting different applications, different applications, using lots and lots of little XML handling programs. We say, use RDF as a hub, and that, at the moment, using RDF as a hub is something you can sell. That's really exciting. The problem is that when you find that everybody else is using RDF, then you have a bust. So that's what I would like to see. I would like to see, initially, you could justify within your particular healthcare application, within your particular science, within your particular discipline, let's use RDF because we want to use the common tools. Get them to use it, but then look forward to the time when everybody else will have done it. Remember, it wasn't exciting using the web initially. You had to have that understanding, vision of what happens if we all do it, and then it becomes very exciting. This is a list of some of the languages. I won't go into it unless you've got particular questions about them. Just to say that if you look with the more complicated languages at the top, the idea is to be able to express, to pass around proofs of how people derive data from other data. We expect people to track where data comes from and who said it, and we expect to use digital signature a whole lot to be able to build trusted systems out of this. The RDF language has been a recommendation for a while. RDF schema is just being revised. It's basically very, very stable. The ontology level is called OWL. It's a more sophisticated schema language, if you like. And that is now pretty stable. It's coming through the last phases of the WSIS process. And now we're just about to start groups looking at the points north, more expressive things such as rules and query languages. Well, there's lots of goals for the semantic web. I don't like putting up this list. Like, people ask, what's the killer app of the semantic web? And the whole idea is, it's not a killer app. The idea is connecting applications together. But what people are very excited about, sort of in the medium term, some of the earlier things, integration across scientific fields, in scientific data, tracking experimental conditions. Which bit of equipment did you use to take that reading? Maybe your instruments will start to record that anyway. And now, because you'll just be able to throw the RDF in with everything else, you won't lose it. So if you want to reuse data and go back and do new experiments by reanalyzing old data, you'll have the experimental conditions in other words. I won't go over that. I'm aware that we're probably running on terribly over time. Allocation. Just some of the challenges. It's difficult to do standards, particularly this isn't going totally under the radar of most people. I'm telling you, for example. So lots of people get interested in it, and the more people get interested, the more difficult standardization could become. Fortunately, it's still pretty much in this, it's like the early days. You know, a few people getting excited and meeting up in working groups, and it's not really suffering from the very, very overcrowded culture and too much press attention. We could have probably the patents. We've done a lot of work with WPC, what a consortium to make sure that make that as unlikely as possible, to make sure that this infrastructure will be royalty free. There's a problem when it comes to a lot of people. They think that the web is done. They don't realize that actually this is one of the more important bits, interesting bits of the web. We haven't done it, and it's difficult to. It is of course difficult to get people to put in that investment when really it's only exciting when there's an unbelievable amount of information out there. So the three phases, if you like. The first phase with the web is why should I need angle brackets for my documents? Why don't I just do it in text? Go away. And the second phase is, okay, we're using your web thing. I guess, or I will be using the web tools, they seem to work. And the third phase is, wow, did you see what I just did? I just did something. Can you believe what's out there? Right? And we haven't got there yet. Right? You can't, I'm not selling it on the basis of that. We have to sell it on the basis of phase 2. I'm waiting for, I'll let you know when I get the first email coming back with phase 3 responses. And we'll all sell it. So, setting the expectations is important. Really people realize that, no, you can't go down and buy trick apps or download your complete semantic web development kit and turn your company into a semantic web company overnight. But on the other hand, there are now a significant number of startups which are totally based on semantic web technology. So, quite a commitment. Some of the large companies who used to poo-poo it are now saying nice things about semantic web and starting groups doing this. So we have to get this, not too fast, not too slow. But you need to set those, try to set those expectations as well as you can. So this is the UI of the second set of slides, which are actually linked from the first set of slides. And I hope that the fact that I've merged and talked together wasn't too confusing. Thanks very much for your attention.
Now we're going to have a discussion here. We've assembled a visionary panel on the issue of science and governance. The basic idea here is that science flourishes in an environment that's really global and really open. We'd like governments to provide such an environment, one that's free to everyone, irrespective of who they are or where they are. So that we can have global and collaborative facilities. In particular, this means having open access to all kinds of scientific data, information and knowledge, particularly information resulting from publicly funded research. On the panel here, to my left is Ion Iliescu, President of Romania. He's here to show us what an engineer can accomplish. A specialist in hydroelectric power and author of such works as the Inventory of Romania's Hydropower Resources, Mr. Iliescu was also Secretary of the Central Committee of the Romanian Communist Party for a brief period in the 1970s. But after taking a stand against the Cultural Revolution promoted by Nicolae Ceausescu, he was gradually removed from political life, and when he supported the specialists in his field against the programs of the Ceausescu government, he was discharged from his official positions and put under the surveillance of the Security, which started to isolate him to cut his lines of communication. On December 22nd, 1989, Ion Iliescu was among the founders of the National Salvation Front Council, and he presented on radio and television a communique to the country that defined the changes that were to decide Romania's future: the annihilation of the totalitarian system, the institution of democracy, political pluralism, and the rule of law, the observance of human rights, guarantee of freedom of expression, and the transition to a market economy. To his left, of course, is Tim Berners-Lee, who we've already met. At the other end of the table here is Walter Leakin. He is head of the Department for International Organizations in the Austrian Ministry of Foreign Affairs. He started his career at the UN Secretariat in New York in the field of international water resources. And after joining the Austrian Foreign Service in 1974, he served in a variety of capacities, including ambassador to Chile and ambassador to Canada. He also led a campaign on North-South independence and solidarity for the Council of Europe, which led to the creation of the European North-South Center in Lisbon. Next we have Professor K95. He's one of the most distinguished scientists in India. He currently teaches at the Indian Space Research Organization, and he also serves as chairman of the Indian Institute of Information Technology in Allahabad, president of the Indian Statistical Institute in Calcutta, and chairman of the Raman Research Institute Trust in Bangalore. In addition, he was a founding fellow of the Third World Academy of Sciences and president of the International Council of Scientific Unions. His research achievements include conducting cosmic ray studies near the geomagnetic equator at high altitude, and the underground studies in India relating to muons, neutrinos, weak interactions, and nucleon decay. Finally, from Cairo, we have Talal Abu Ghazala. He is vice chairman of the UN ICT Task Force and chairman of the International Chamber of Commerce Commission on E-Business, Telecom, and IT. He's also chairman of the largest group of professional services in the Arab world, such as accounting, consulting, intellectual property, and legal services. He himself is a consultant, mainly in IT. I'm going to ask each of the panelists to speak from the table here and for about 5 minutes or so. And one by one, and then we'll have some questions. Mr. Elias.
Thank you very much, Mr. Chairman, distinguished attendees and gentlemen. After such an inspiring and high professional intervention on the web, allow me some remarks on the item of our center concerning the role of the science in the information system. Science has played an important role in the history of human civilization, and in the modern times it represented the foundation for the economic and social development of society. We have enough examples that justify us to say that the decline or disappearance of some civilizations stems from the ignorance or marginalizing the scientific and technical communities, from persecuting the scholars and replacing the graduates. Developing countries can be accomplished without a methodical, open, and steadfast approach of the goals included in the UN Millennium Statement. It takes the firm political will of all the governments, the strengthening and the enlargement of the public-private partnership in order to achieve this. I believe that information and scientific and technological knowledge, alongside the fundamental resources such as water, food, education, as a rest between democracy and economic growth. The open societies which consolidated democracy will be favored, as the development of science depends essentially on the existence of a political and intellectual environment that is open, proactive, stimulative, and tolerant of the different and even critical approaches of the realities. As the creation processes are cumulative in time and space, the discontinuities, particularly in the field of the access to information and knowledge, as a product of some political, ecological, or religious constraints, can result in development delays, poverty, social, and civilization exclusion. The creation of the information society and the development of the economy of symbolic goods and knowledge in the service of all the inhabitants of the planet entail not only the definition of the role and place of science in society, but also the creation of some global technical scientific facilities, or some mechanism of free access to scientific knowledge, particularly to those financed with public money. In order not to waste the resources, the definition of the scientific priorities at the planetary level is needed, which should lead to the setting up of some research programs open to all the global actors, public and private alike. I would like to extend my appreciation to the initiative taken by CERN, acting under large international cooperation framework, that led to the development of certain transforming structures for the information society, which made possible the amendment of the green application. This specific application will allow the sharing of IT resources regardless of their geographic position. A Romanian consortium, which involves at the same time representatives for the research and development, academic and business communities. I hope of our relations with all and our fellows of the increase in the level of our participation.
I didn't follow it because I was sort of thinking about the pieces of before. Originally when Oxford University did physics, it was called experimental philosophy, which I think is kind of cute. And when we did some of our consortium, we said we didn't do everything except philosophy. But now it turns out this might we do more and more of it. But the idea of physics as experimental philosophy is going to be to consider that maybe we should call the building of the semantic web philosophical engineering. They're both kind of connected with who are we, why we're here, and sort of the fundamental questions. One is basically seems to be analytical, and one of them seems to be synthetic. So science is constantly asking the question, why, and engineering, because when we talk about building the internet society, we're always asking the question, how? And it seems to us that how we're forced to look at the question how it's forced on us by needs to have lunch and dinner or roof over our heads. But the question why comes from somewhere deep inside. But when you look at them, if you look at them look at any analysis of really what leads to what, we're here to discuss something. Well, why are we here to discuss something? How are we going to discuss it by coming here? Why and how are inseparably just the same question. It does different sides. They're the yin and the yang of the same thing. You can't separate the analysis and the synthesis. If you try to really build anything, if you try to build engineering to create an information society and you're not doing science at the same time, in the same sentences, then you have it's simply a contradiction. I feel that science is completely inseparable from building the information society.
The odd man out. I'm a diplomat. Having said that, let me look at what the topic of our meeting here yesterday and today was from the global diplomatic governance perspective, and make a few comments on that. I see number one, I see that there is, and I live it every day, a growing complexity of our global agenda. In fact, it is shown it was global and at the same time, and this is new verticality, it reaches down to the citizen. Our new global agenda has the citizen as actor and as victim at the same time, and then all the levels of societal organizations, from the communes, the cities, nation states, to the global level. Now, having said that first, let me try to define that term that is used to describe this new process, participatory process, global governance. What is global governance? Well, first, governance, as I like to use, is in the global context, different from government, which is a vertical process of norm definition and implementation to lower levels of implementation.
Governance is a horizontal process of interaction between the public structures of decision-making and the affected and contributory elements of society at all levels of societal organization. That includes the global level. Global governance is therefore a process that has moved away from interstate diplomacy, where only diplomats sit behind not name shields, but state shields. Not that this means that we have a withering away of the state in, I'm quoting, yes, in global affairs. No. We have in fact something emerging that is similar to the political processes at the national level. We have input functions, we have providers of input functions, we have a decision-making process from which those who provide input are excluded and should be excluded for lack of legitimacy and mandate, and there are output functions. Now, academia provides, as I in my first sentences tried to define, a very important input. Where is it? In fact, I must say in the WSIS preparatory process, apart from this very important conference, academia was not named. There was a talk about civil society and to talk about multi-stakeholders and stakeholders, but academia was in the process, except as an intergovernmental organization. In fact, CERN fortunately took the floor several times, but it wasn't really, and it's not in the text. Academia is not mentioned in the Declaration of Principles. And this raises, in my opinion, for the future, the classical question: where do we go, and how do we go?